I'll explain optics, which stands for ordering points to identify the clustering structure. It's a clever algorithm that groups data points based on their density. Think of it like this: densely packed points form clusters, while sparse, isolated points are considered noise. Optics is an improvement over another algorithm called DBSCAN because it handles varying densities more gracefully. These are the individual pieces of data you're trying to cluster. Each data point is represented by its features or attributes, and optics uses these to calculate distances between points. This is where optics gets really interesting. The reachability distance, often called SHI, pronounced KSI, measures how far away a point is from its furthest neighbor that is still considered density reachable. This means you can find a path from the point in question to its furthest neighbor via a sequence of points that are all close enough to each other. A small SHI value indicates a point surrounded by closely connected points. A large SHI value means the point is relatively isolated. It's a key element for understanding where the cluster boundaries are. The core question is to test understanding of opticsx's SHI value and its interpretation in identifying clusters within a dataset. We are going to evaluate statements about the meaning of these SHI values. This question is designed to assess your knowledge on how to interpret the SHI values output by the optics algorithm. We'll look at several statements and evaluate if they are true or false based on our understanding of optics. This is the title, which encapsulates what we'll explore: the optics clustering algorithm and the important concept of SHI, reachability distance, values. This row number refers to option C and its meaning. This row number refers to option D and its meaning. This row number refers to option A and its meaning. This row number refers to option B and its meaning. This measures how far a data point is from its furthest neighbor that's still considered close enough. Think of it like this. Imagine you're at a party. Your reachability distance is how far away the furthest person is that you can still easily chat with, considering everyone in between is also close enough to have a conversation. This refers to how many data points are clustered together in a particular area. A high cluster density means lots of points are close. A low density means points are spread out. These are points that are isolated. A noise point is like a single guest far away from everyone at the party. A sparse region would be like a small group of guests standing far away from the main party. They don't have many close neighbors. These are individual observations or measurements in your dataset, each represented as a point on the graph. They are the fundamental elements that optics algorithm analyses. This is the overall topic and introduces the concept of interpreting the meaning of SHI in the context of optics clustering, a technique in machine learning used to group similar data points together. I see that you're working with density-based clustering. This is a type of clustering where you group data points based on how densely packed they are. Think of it like this: dense clusters are like crowded cities, while sparse regions are like deserts. Optics is one clever algorithm that tackles this. This is a crucial concept in optics. The SHI value, or reachability distance, measures how far away a point is from its most distant neighbor that is still considered reachable by the algorithm. In simpler terms, imagine you're a point in a city. Your SHI value represents how far away you can see before running into an area that's not connected or part of your neighborhood. Optics, or ordering points to identify the clustering structure, uses reachability distances to form clusters. We interpret the SHI values to understand the structure of our data. A high SHI value means that a point is isolated, while a low value means it's embedded in a cluster. Optics is a density-based clustering algorithm. It's like a sophisticated mapmaker. Instead of just marking clusters, it gives you a detailed map of where the dense areas and sparse areas lie, making it superior to other algorithms such as DBSCAN in certain scenarios. The SHI value is a key part of this map. This question tests your understanding of what SHI values signify in optics clustering. Remember, the focus is on interpreting the SHI values. It is not a computational question, it's an understanding question. I'm explaining optics clustering, a method to group data points based on their density. We'll focus on understanding the SHI value, a key part of this method. Think of it like this: SHI tells us how isolated or connected a data point is within its neighborhood. A high SHI value means a data point is far from its nearest tightly packed neighbors. It's like an island, isolated. This suggests it's either noise, a random data point, or in a sparse area of low density. Think of it like a lone tree in a vast desert. A high Xi value indicates that a data point is either noise, meaningless data, or located in a sparse area, where points are spread far apart and not tightly clustered. A low Xi value indicates that a data point is surrounded by many close neighbors, similar to a dense forest where trees are clustered together. A low Xi value means a data point is surrounded by closely connected neighbors. It's part of a tightly knit community. This suggests it's likely in a dense cluster. I interpret Xi as xi, representing the reachability distance in optics clustering. It's a measure of how far a data point is from its furthest neighbor that's still considered densely connected. Think of it like this. A point with a high Xi has faraway neighbors, it's kinda lonely. Conversely, a low Xi means it's close to lots of buddies. In optics, each data point has a Xi value that helps us understand its place in the clustering structure. It's like each point has a social radius, determined by how densely packed its nearest neighbors are. Optics, or ordering points to identify the clustering structure, is a density-based clustering algorithm. It's a smart algorithm that accounts for the varying densities within a dataset, unlike some other algorithms that struggle in areas with different densities. The Xi value is key for optics to do its clustering magic. I see it as the algorithm's clever way of figuring out which points are close-knit and which ones are more isolated. This question tests our understanding of how to interpret the Xi values, which are essentially a measure of how isolated or connected a data point is within a dataset. I'm looking for correct statements about what a high Xi or low Xi indicates. This is the main topic, understanding how the reachability distance, Xi, helps in optics clustering. It's all about figuring out if a point is in a dense cluster or a sparse region, or noise. A high Xi value means the point is far from its nearest densely connected neighbors. It suggests that the point is either an outlier, noise, or in a sparsely populated area of the dataset. A low Xi value means a point is surrounded by densely connected neighbors. That means it's likely part of a dense cluster. This is incorrect. Xi values are relative to the dataset. They can't be compared directly across different datasets because the scale of distances varies. This is also incorrect. Xi represents the distance to the farthest density reachable neighbor, not the nearest. I see you're tackling optics clustering. This is all about understanding how the reachability distance, or Xi, helps us find clusters in data. The Xi value is a key to unlocking the structure of your data. Let's clarify the basic units we're working with. Each individual data point. Think of these points like dots scattered on a map, each representing a single observation from your dataset. A low Xi value means the data point is surrounded by its buddies. It's snuggled right in the middle of a tightly packed group, a dense cluster, a party. The neighbors are close by. A high Xi value, on the other hand, indicates isolation. The point is far from its closest densely packed neighbors. This point might be a lonely noise point or it might be in a sparse region of the dataset, far away from the action. This is the core of optics. Xi measures how far you need to go from a data point to reach its furthest neighbor that's still connected through a chain of dense points. It's like figuring out how far you need to walk from your house to find the farthest house that's still connected via a close-knit neighborhood. This question is all about testing your understanding of what Xi tells you about your data. Let's analyze each statement carefully. This is the title of the quiz, focusing on understanding the meaning of Xi values within the optics clustering algorithm. I'll help you understand what optics is and how to interpret those Xi values. Get ready. I'm asking you to determine which statements about Xi values in optics clustering are true. We'll go through each statement carefully. This is the core question. It tests your knowledge of how to interpret the Xi values that optics clustering produces. You need to understand the algorithm's meaning of these values to answer correctly. Let's dive into it. A high Xi value means a data point is far from its nearest tightly clustered neighbors. This suggests it's an outlier, noise, or in a sparsely populated area. Think of it like finding a single house in a vast desert. It's far from any town or neighborhood. A low Xi value means the point is surrounded by many close neighbors. It is densely packed. Imagine it like living in a crowded city. Many buildings are close together. This statement is false. Xi values depend on the dataset's scale and distances. You can't directly compare them between different datasets. They are relative to the dataset in which they are calculated. This is also false. The Xi value is the distance to the asterisk farthest reachable neighbor, not the nearest. It's about the furthest point you can reach from the current point while staying within a densely connected area. These are the options to choose from in answering the question. This refers to a single observation in your dataset. Think of it as a single data point on a graph. These are the data points that are close to the point you are considering in the clustering algorithm. The closeness is determined by distance and density thresholds within the optics algorithm. Xi, or reachability distance, measures how far you can reach from a given data point before you hit a less dense area. A small Xi means the point is surrounded by densely packed neighbors. A large Xi means the opposite. This is the key concept in this quiz.